We begin Unit 17, Laws of Logarithms. The equation of the inverse of an exponential function can be written as the logarithmic function of the same base. Conversely, the inverse of a logarithmic function is the exponential function of the same base. They are inverses of each other. What is the inverse of the function 2 to the x power? Well, first we denote that this is an inverse function, and it is written as the log base 2 of x. Notice the base is the same in both pieces. In the exponential function, the base is a big 2 with an exponent of x, but in the log function, the base is a little 2, it's a subscript on g, the x is a big X. We want to graph the function 2 to the x power and its inverse on the graph below. So using our calculator, under y equals, raise 2 to the x power, and we go to second table. We want to pick points on either side of 0, so -1 is 0.5, 0 is 1, 1 is 2, 2 is 4, and 3 is 8. Plot these points on the graph and draw the curve. We learned from the last unit that this is exponential growth. And remember my domain in this graph, the arrow is going to -infinity on the x, and the y values are in positive infinity in this quadrant. And where this arrow is heading, the x values are positive infinity, and the y values would be positive infinity. Any point I pick on the line would give me those values. So therefore my domain, since it is going from -infinity to positive infinity, it's going to be all real numbers. This is a recap on something we've already discussed in the very first unit, parent functions. Our range, those are the y values, is heading from positive infinity to positive infinity. So there are no y values less than 0. So my range are all the y values greater than 0. Not equal to 0, because you can see here that this is our asymptote. It does not cross this line. And again, if we look at the calculator, we can see under the table that the y values are getting closer to 0, but it does not cross. And at this point, it is so close to 0, but it will never cross. These numbers never get into the negatives. Now we need to graph the inverse function, log base 2 of x, on the same graph. To input this into the calculator only reads common logarithms. The common logarithm button is right here underneath the x squared key. And the common logarithm is understood to be a base 10. So this is log in parentheses, plug in your x, divided by log, and since the base is a 2, this is what we put in for x into the calculator. So let me clear it. Move this up so you can see. I'm going to put in log x, because this is the big number here. Whatever this number is the same number that goes inside the parentheses. Division, log again, base 2. Now we go to second graph, which is our table. When you get 0, there is an error. So at 0.5, I have -1. 1, I have 0. 2 is the y value is 1. 4 is 2. And 8 is 3. So let's plot these points. When we graph the inverse function, log base 2 of x, we can see that the graph is indeed a reflection over the line y equals x. The log base 2 of x, the x values are going from positive infinity to positive infinity. X has to be greater than 0. The y values are going from positive infinity to negative infinity. And the y values then would be all real numbers. So the inverse, it just switches on the domain and range. Whereas before, the domain was all real numbers. Now the range is. And the range was greater than 0 on the exponential function to the x power. But now the domain is. So for our assignment, we will write the inverse of the following functions. Then we will graph both the function and its inverse on the same set of axes. Always start with the graph of the exponential function, whether it is the original function or the inverse. So we're always going to start with the graph of the exponential function. The little base, log base 3 of x, becomes my big base of the exponential function. The x becomes my exponent. Now remember, I said that we are going to graph the exponential function first. Plug in 3 to the power of x into the calculator. On the homework assignment, we are also going to graph y equals x on the same axis as the exponential function and its inverse. Looking at the graph in the calculator, we see that it starts out really high, it curves at 0, 1, and it gets closer to 0, but it does not cross. We can also validate that via the table. Now let's figure out our domain and range, and this is going to be just like our parent function. The domain is going to be all real numbers, and the y values are going to be greater than 0. Not equal to, because it cannot cross the line y equals 0, so it can't be equal to. That's my asymptote. Okay, now let's graph log base 3 of x. In the graph, we can see that log base 3 of x is going to be coming in here. It will never touch x equals 0, or the asymptote. The domain is x is greater than 0. And just looking at the graph, it makes sense. All these values where the purple is are greater than 0. And the range includes all of the numbers, so the range is all real numbers. In example 2, we're going to start with the exponential function, 5 to the x power. This is what I will put into my calculator to graph. This exponential function looks like this. It will not cross y equals 0. That is the asymptote. So it will get closer and closer to that line, and we can see that it's rising. You can also validate this with the table. Let's get some points in here and graph it. So these numbers are so small, I'm going to try not to pick those. 0, I have 1, 1, 5. If I go out 2, I am going up 25. So let's graph these points. Again, we also need the line y equals x on our graph. The homework assignment does ask you for the line y equals x. Notice that while I'm graphing these, I am labeling the graph. Since I have 3 of them, I need to know which one is which, and if you don't label it, I don't know. Also need to label the axis, the x and y axis. The domain on this exponential function is all real numbers, and the range is all the values greater than 0. Now we need to graph the logarithmic function. Say the inverse, remember this becomes the base of my logarithmic function. So I have log base 5, so this is a little bitty number here, little subscript, of x. X is the same size as the log. This is what I need to put into my calculator. Remember, we want to put in log, L-O-G. Our x goes here, divided by log, and the little 5. Okay, now we go to the table and Notice that all of these are errors. All the negative numbers are errors. 0 is an error. 0.5 is negative 4.3. So I'm trying to find the next whole number. 1 is 0. Okay, now that we have graphed the inverse of x on the graph, we can see most definitely they are inverses of each other. They reflect across the line y equals x. The domain of the inverse function is x is greater than 0, which makes sense because all the values on this blue line are all greater than x. X is doing nothing but increasing. 1, 2, 3, 4, 5, 6. There's no negative values. This graph is not even on the left side of 0 here. And the range is all real numbers because it's going from negative infinity to positive infinity. Let's look at one last example. The function 1/2 raised to the x power, this is an exponential decay, never touches 0, so y equals 0 is the asymptote. Let's look at the table, and I'm looking for some whole numbers. As the x values get smaller, the y values get bigger, and we knew that by looking at these graphs. -1, -2 is bigger, -3, the x value is way up here. So I'm going to choose -3 because that's on the graph still with an 8. -5 is at 32. -4 is at 16. So I'm going to use -3, 8, -2, 4, -1, 2, and 0, 1. Graph this equation, label the x and y axis, and also graph the line y equals x on the graph. The domain of f of x is all real numbers because the x values, all the negative values are included and all the positive, so all real numbers. And the range, since it does not cross 0, it doesn't even touch 0, y is greater than. Now also notice here, this function did cross y equals x. So I'm curious as to what the inverse is going to look like. I know that I have log. The base of my exponential function is the same base for my log, so this is a little bitty 1/2. It's like a subscript. And the x is the same size as the log, so this is what I'm putting into my calculator. Remember, we put in log, and the x, or the big number with the log, goes in first, divided by log, and the base is next. So we divide it by the base. And now if I look at my graph, this graph does not cross x equals 0. That's its boundary line. It comes down and it goes to infinity down in the 4th quadrant. Let's get some points for this graph. Oh, all of these are errors. So starting at 0.5, 1, 0, 2, -1, 4, -2, and 8, -3. Let's plot these points. Okay, now we have graphed the inverse function. Make sure you label each of these graphs as to which function they are. because I can't tell if you don't label them. The domain of the log base 1/2 of x are all the numbers bigger than 0, so x is greater than 0. And the range is all real numbers. Make sure that on your homework assignment, make sure that you do graph y equals x so that you can see that they are reflections across this line. Also, make sure that you label each line. This concludes flaps 1 and 2 of your Unit 17 Photable.